All right, so this is the second video where we're talking about graphing rational functions. So please make sure you've watched the first video to get the basics down. Here we're going to add one more dimension to it. But just to really quickly review, a rational function looks like this, where you've got some sort of polynomial on top of the fraction, and then you have a different function on the bottom. So there's just a polynomial. You should notice that it hits the x-axis at -1, 0, and 3. And those come from if we were able to factor out this equation. If we put it on another polynomial on the bottom, something like x squared minus 16, then we get this really funky looking rational function here. And what I want you to notice are a couple things. It still hits the x-axis at 0, -1, and 3. And the reason it hits the x-axis at those 3 points is just the same reason that the polynomial hits the x-axis at those points. And so what I want you to think about is if you have an equation like this equation, and if you tried to set it equal to 0, whenever you have an equation, you can multiply both sides by whatever you want. So if I multiply both sides by x squared minus 16, x squared minus 16 over x squared minus 16 cancels out, and so does 0 times x squared minus 16. They cancel out in different ways. On the left side, something divided by itself equals 1, so you have 1 times the numerator, just you have the top left over. On the right side, 0 times anything equals 0, so you have nothing there. And that's why the original polynomial that I had before I typed in a fraction and the rational function that I had after I typed in the fraction have the same x-intercepts, because the same numbers that make the polynomial equal 0 will make the rational equal 0. The new thing that happened is I put a new polynomial on the bottom, and x squared minus 16 can factor to be x plus 4 times x minus 4. The top has a common factor of x, and if I take out an x, I can do x minus 3 and x plus 1. And now you can see all of those relevant pieces of information, that there are vertical asymptotes at 4 and at -4. And that's because if you plugged in x equals 4, you would get divided by 0. Not 0 in the numerator, that's an x-intercept. 0 in the denominator, that is a vertical asymptote. Okay? Then you'll notice one other thing, that if you zoom out, it looks like a line. If I zoom out here, and I doubt my lines that I drew are gonna stay nice, but we'll try. If I zoom out here, actually you can see that it looks like the line y equals x. And the reason for that is if you cover up everything except for the leading terms, you get an approximation. It's approximately equal, come on pen, to x cubed over x, which is just x. In fact, if we type in the equation, oh, that's weird. I didn't expect that. If we type in the equation y equals x, you can see that it is approaching that equation as we zoom out. And so that's kind of like the idea of a horizontal asymptote we talked about in the first video, where you look at the ratio of the leading terms. Just in this case, the ratio of the leading terms leaves you with an equation y equals x instead of a constant like y equals 1. Okay? So what I'm going to do next is just flip over the function that we typed in, and let's just compare. So if I just copy this down here and bring this on top, and then bring this on the bottom, come on, don't fail me, there we go. Then I hope you can see how they're similar, they're related, they're just a little different. What's different about them is that now it has two x-intercepts at 4 and -4, because that's what makes the numerator equal 0. And now it has 3 vertical asymptotes. It has a vertical asymptote, let's see if I can find all 3 of them. It has a vertical asymptote at x equals 0, because that would make the denominator 0. as a vertical asymptote at x equals -1. Let's make that one blue as well. And it has a vertical asymptote at x equals 3, because those are now what would make the denominator equal 0. So there's only one other thing, really, that I want to show you about rational functions, and that is the idea of a whole. So let's look at something that seems simpler than it is. Let's look at x plus 3 divided by x plus 3. This may seem just to be the number 1, because we always say anything divided by itself is equal to the number 1. However, if you zoom in really close and you look at x equals -3, come on, don't fail me now, you'll see there's a little hole that shows up in the graph, and it says the word undefined. And the reason why is because if x equals -3, then what happens to your equation? Well, then you have -3 plus 3 on top, -3 plus 3 on the bottom, and that makes 0 divided by 0. 0 divided by 0 is undefined. It's undefined to just give you one tiny gap in your function. And so earlier when I said that whatever makes the top equal 0 is going to be an x-intercept, and whatever makes the bottom equal 0 is going to be a vertical asymptote, that is true except for if it makes both equal 0 at the same time. So the statement I said is really only true if you simplify your rational function first. So I'll finish up with one example where we start with one and simplify it and identify all the features of it. So let's say we had x squared minus 5x and then minus 24 divided by x squared minus 9. Okay, if I wanted to factor the top, the factors of the top are x minus 8 and x plus 3, because those two factors, -8 times 3 is -24, -8 plus 3 is -5. And if I want to factor the bottom, I can factor it to be x plus 3, x minus 3. And now you can see that my two graphs land right on top of each other. And remember, that's a really good way to check your work. What you hopefully notice is that both top and bottom share an x plus 3. So because x plus 3 canceled out, I know that x equals -3 is a whole. And I can look at my simplified equation to figure out all of the other. I don't know why it's doing that. I'm jumping the letters down. That's weird. Oh well. And I can look at my simplified equation to get all the other pieces. The value that makes the top equal 0 tells me that 8, 0 is a root. This tells me that x equals 3 is a vertical asymptote. And if I look at the leading terms, x divided by x, which by the way is the same as the original leading terms, that's going to be equal to 1, and that's my horizontal asymptote. And so you see, first step is always to factor and simplify. If any factor cancels out from the top and the bottom, then that gives you a whole. And then the simplified numerator tells you the x-intercepts, and the simplified denominator tells you the vertical asymptotes, and the y-intercept is left over as 8/3. And where did I get 8/3? Because that's -8 divided by -3, or in the original problem, -24 divided by -9. All right, let me know what questions you have. Happy to help.